All right, hey everyone, I'm Bavshot. For the past 4 months, I've been an automation intern with research operations. And the crux of my internship has been collecting data, harvesting data for Vector and its projects. Since I've been a part-time intern, I haven't focused on one big project, but there have been 3 smaller ones. First month, I collected data from conferences such as NeurIPS to measure Vector's impact from faculty. Next, I focused on CSRankings. We wanted to see where Vector stood in relation to competing AI institutes and view Vector's ranking for that. Third, were Google Scholar Pools. If you take a look at Vector's website right now, it's quite out of date. The last publication on there is from 2019, and we don't want that. We want to get that up to 2022, which is most current. First off, conference data. We wanted to know the outcomes of faculty submitted papers to these conferences. Conferences included CVPR, ICLR, ICML, and NeurIPS, but this is a lot of data. There are hundreds of papers that are submitted to these applications, to these conferences, and you guys not able to hear me at the back? Is this better? Okay. So this is a lot of data. Assigning human resources to collect this data would be a big waste of business resources, and it would take probably weeks, maybe a month to go through this. And that's not really good use of resources. So we want to automate this process, and the way we do this is by scraping these websites for conference data. Because all this information is publicly available, we can just go to these websites, collect the data we need, and then selectively filter out the researchers that we're looking for. So I've built off of the work of a previous intern, but the solution to this was making a script which is able to fetch data from these websites. How does it work? Since these websites vary from conference to conference, and they can even vary from year to year because sometimes there are little changes that are made, we want to be able to make a solution that's easy to deploy to any new conference that we want to take a look at. Manually having to go through the code would be, it would consume a lot of time again. And so the settings that this tool needs are given to it using a JSON file. And we can even specify the classes and tags that we want to look for in the HTML through this JSON file. By doing this, this removes the need for future interns to have to go through the code and update this tool manually. This scraper uses Beautiful Soup to build an object which can be parsed. And essentially, if a name matches up with the input requirements that are fed to it through the JSON file, the researcher and the corresponding publication, whether it be from a workshop or an actual publication, then it's added to the output data set. So there were a few limitations that I faced with this. Again, websites may change, but because of the JSON input format, we're able to easily and quickly update the scraper to meet the needs of a particular conference. Researchers sometimes, they go by different names. So because of different languages and just the way names work, we had to include aliases for researchers with slightly different names in different languages. The current solution to this, since there are a few researchers that have this situation, is to just add another column to the input settings to search for an alias. And this works out because, again, there are only a couple. This scraper would reduces the work required from people having to manually go through these publications and these websites from hours to a matter of minutes. The next project I worked on was the CSRankings project. We want to figure out how Vector stacks up in relation to competing institutes. To start off, vector doesn't appear in the official CSRankings list, so we have to go in and add that. Next, we wanted to get vectors data on CSRankings. So the existing data set is organized alphabetically with researchers' names added to, I think, their CSV files. So researchers must appear on DBLP, which is a reference on major computer science publications. So there were a few researchers that we had to take out, but maybe their names will be added in the future and we can further improve our ranking. These researchers that we want to add from Vector Institute, they're added onto CSRankings data set. We made a clone of this so that we could edit this on the fly. And this resulted after some selective filtering, Vector being a top 10 AI institution. So to get to the top 10, it took some finessing. So the thing is, Vector is relatively new compared to these other institutions, which can be they can be hundreds of years old. And Vector is obviously not hundreds of years old. So we had to filter publications over the last few years. This filtering led us to choose the years starting at 2017. Furthermore, our faculty is primarily focused on AI, whereas these other institutions have faculty in theory and computation as well. So by removing these other fields, this further bumps up our ranking. And certain conferences work better for Vector. For example, we have many more publications in Europe as opposed to conferences that competing institutions may participate in. And after this, we got the top 10, which was the business goal. And next, we got Vector website publication updates. So as I said earlier, the last publication on Vector's website is from 2019, which isn't great. The thing is, there are hundreds of publications by faculty at Vector, and having to go through these publications and asking the faculty individually would take several months, and it would also be a waste of human resources. So my job was to figure out how do we automate this process. First, we got to figure out how we're going to get the actual publication data in the first place. This data is publicly available on Google Scholar, but Google doesn't like bots crawling their services, and there is no public API that we can use to navigate publications like Google Scholar. So this was one of the problems that I had to overcome. There's several options that we could have used here. First, I could try libraries written by others. I could use proxies to try and circumvent bot protection, but this is a losing battle when you're fighting someone like Google. Next, we can use premium services, which circumvent the bot protection, but this somewhat defeats the purpose of my internship. So option number one is what was the option that I chose to go with. And the library that I chose to use was Scholarly. Some of the advantages of this library were that I can choose to make non-blocking requests, which was the primary problem that I faced. By choosing to make non-blocking requests, we were able to get the data we needed without Google blocking our scraper. But this process is slow. If we were to let this scraper run sequentially, it would take over 24 hours just for 43 researchers, which isn't great if we want to modify something or we want to change something when we're scraping for the actual data. We want to be able to speed this up so that we can quickly analyze the results. So the solution was to use multiprocessing to take advantage of multiple cores on the laptop I'm working on. So the question that you may have is, why choose multiprocessing over multithreading? Some of the pros of multithreading is that it's lightweight, has a low memory footprint, but the thing is, there is a possibility of race conditions, and the code is harder to manage as well. With multiprocessing, there is a separate memory space. The code is more straightforward, and we can actually take advantage of the multiple CPU cores, which was the goal in the first place. Since the requests were non-blocking with the Scholarly library, we can concurrently make requests. And since the order of the requests was not important, because researchers were divvied up by their names, and we can easily sort the data later on by year of publication, we were able to make the requests in any order that we wanted. This resulted in a performance improvement from about 24 hours to 45 minutes. Some of the next steps, because I am returning for the next 4 months, and this project is still a work in progress. Now that the data has been collected, we need approval from faculty to actually include these papers. This will be sent out using an email, and they can selectively choose publications that they want to appear on Vector's website. Next is just adding the data to the website. This is a relatively short step since we have the data that we need. Furthermore, we want to automate this process because we don't want to end up in this situation again. So a tool we can use for this is GitHub Actions, where it automatically parses Google Scholar after a certain period of time has elapsed, and it updates the publications on Vector's website using comparing what's new and what we already have. Big thanks to Mark, Jackie, and Clarence for helping me out throughout the internships. If you guys have any questions, I'd be happy to take them.
I guess I can start us off again. Yeah, I was curious about how far back in time we're going. Are we looking at sort of our ranking with respect to the foundation of Vector, or are we looking at sort of the contributions of Vector faculty throughout their career, perhaps predating the founding of Vector?
So since Vector faculty they're somewhat new to the research area, right? Some people have recently just finished their studies and they're just coming on it, so they don't have many publications. Whereas the other institutes, they have researchers that have been in the field for several decades. And to remedy this, we chose the year 2017 as a baseline, which allowed us to rise up through the ranks.
I also have a question online. Amir Mohammed, if you want to go ahead.
Well, thank you for your presentation. It was great work. Regarding the task you were mentioning about the multiprocessing, so I'm not sure if I got it correctly. Was it for somehow scraping the scholars or scraping the papers or something like this? This is my first question. And the second one is that actually when you're using, whether you're using multi-thread or multiprocessing, when you get the data, for example, if you're using, for example, 4 threads, after that, the problem we face is we have the data, but we are somehow including it in different data files. So are you having, for example, another step, for example, for integrating the data or something like this?
Yeah, so to answer your first question, the data is scraped from Google Scholar. I don't do that myself because the scraper would be very easily blocked by Google's bot protection. So what we do is use a library which is able to make these requests that don't face this problem. So yes, it is scraping. To answer your second question, the data is just appended to an Excel sheet where the faculty will be able to choose which publications they want to add. There's no specific ordering to that. Whenever the results are obtained, they're added to the Excel sheet.
Okay,
Does that
great.
answer your
Thank
question?
You. Yeah, that's okay. Thank you.
I had one more question.
Yeah.
What stack did you use to do the scraping? Was it some Python package or was it some front-end framework that does the testing? And if I can recommend, if you open up an AWS Lambda and it's like 10, 15 lines of code, it will use a different IP every time you try to do so, then you won't hit the rate limit or the thing. So, yeah, that's one thing you could try. But yeah, what stack was used for this?
I just used Python, and for the conference scraping, it was Beautiful Soup along with another package to scrape the actual publications. And for Google Scholar, it was Scholarly, which was able to make the non-blocking request. So I didn't have to use AWS to do any of this.